Here in this problem, we need to obtain the derivative of a function with respect to another function. To solve such a problem, we will begin by considering a function u, which is a function of x, to be equals to inverse sine of 2x over 1 plus x squared. And we will consider another function v, which is given by cosine inverse of 1 minus x squared divided by 1 plus x squared. Now that means our goal will be to find out the derivative of u with respect to v. We'll need to find its value. So let's begin. Now before taking the derivative on both sides of u with respect to x, we will need to simplify the expression on the right hand side. So here we will use some trigonometric substitution to simplify this. So let's begin by, suppose we consider x to be equals to tangent of theta. So when doing that, we will get u equals to sine inverse of 2 times tangent of theta divided by 1 plus tangent squared theta. So here we have substituted x with tangent of theta. Now we know that 1 plus tangent of theta, tangent squared of theta, so this is an identity which is secant squared theta. So that means we have u equals to sine inverse of 2 times tangent of theta divided by secant squared theta. When we write tangent of theta in terms of sine and cos, we have 2 times sine theta divided by cosine theta. Multiplied to, we have 1 over secant squared theta. Now we know the secant theta is the reciprocal of the cosine function. So it goes to the numerator, it will simply become cosine squared theta. So this will be equals to sine inverse of 2 times sine theta times, so we have 1 cosine of theta from the numerator and 1 from the denominator cancelling out to give us cosine theta. So this will be equals to u. So that means we have u equals to sine inverse. Now 2 times sine theta times cosine theta, this is again an identity which is given by sine 2 theta. So let me mention it here, that sine 2 theta, so that's equals to 2 times sine theta times cosine theta. Right. Now we have sine inverse of sine theta, which is simply u equals to 2 times of theta. Now here u is a function of theta because we have made a substitution. X is equals to tangent of theta. Now if we bring back theta and write it in terms of x, then our function u will be equals to 2 times inverse tangent of x. So this is the simplified form of u, which is 2 times tangent inverse of x. Now before taking the derivative, we'll simplify v as well. So v is given by cosine inverse of 1 minus x squared divided by 1 plus x squared. So here also we'll have to make a trigonometric substitution. So here we are going to suppose that x is equals to tangent of theta. Let's take tangent of phi instead. We have already taken theta. So that means v, which will now become a function of theta, this will be equals to cosine inverse of 1 minus tangent squared phi divided by 1 plus tangent squared phi. Now we have cosine inverse of, so what we can do, we can convert tangent to its ratio, sine over cosine. So this gives us 1 minus sine squared phi divided by cosine squared phi whole divided by 1 plus sine squared phi divided by cosine squared phi. Right. Now we'll simplify the numerator and the denominator. That means we'll multiply the numerator with cosine squared phi and then multiply the denominator with cosine squared phi as well. So this will give us cosine squared phi minus sine squared phi divided by cosine squared phi plus sine squared phi. Now the denominator, cosine squared phi plus sine squared phi, that's an identity with a value equals to 1. So we get cosine inverse of cosine squared phi minus sine squared phi. Then again we have an identity which is cosine squared phi minus sine squared phi. So this is equals to cosine inverse of cosine of 2 times phi. So this is an identity and this is our v. So that means we have v equals to cosine inverse of cosine of 2 phi, which is simply 2 times phi. we considered phi to be equals to, tangent of phi to be equals to x. So that means phi will be equals to tangent inverse of x. So v is given by 2 times tangent inverse of x. So now that we have u and v, our task will be to find the derivative of u with respect to x. So that's the same as taking the derivative of 2 times the derivative of tangent inverse of x. So that will be equals to 2 times, we have tangent inverse of x, its derivative is a standard formula, which is 1 over 1 plus x squared. Similarly, when we take the derivative of v with respect to x, we also here have 2 times tangent inverse of x, so that will be 2 over 1 plus x squared. Now, we want to find out du over dv, that means derivative of u with respect to v. So this is simply taking our derivative of u with respect to x and dividing it with derivative of v with respect to x, which gives us 1. So that means our final result, the derivative of the given function with respect to the second function, which is cosine inverse of x, this is equals to 1.